Today we're going to graph linear inequalities on a coordinate plane, which is very similar to graphing lines. Now, if you remember, we graphed on a number line equations like y is less than 4. Let's go ahead and graph it on a number. So at 4, this should just be a review, we would have an circle because it is not equal to 4 but less than 4. So our y values would be everything to the left because less than is to the left. Now we are going to do the same thing, but we are going to graph it on a coordinate plane. We are going to graph the line y equals 4, which should be familiar to us. If you remember, when you have y equals a number, that is going to be a horizontal line. So we are going to graph everything, or every point, where y would equal 4. Okay, before we keep going, just like on our number line where you have an open circle and a closed circle, we have to be careful about how to graph our line. So really quick, let's go over what I mean by that. Just like our number line where we had an open circle, these were for the inequalities less than and greater than. On our coordinate plane, we are going to use a dotted line to represent these inequalities. So where we had a closed circle on our number line, so for less than or equal to or greater than or equal to, we are going to use a solid line. This is representing that at these lines it can equal the coordinates on the line, but on these lines it cannot. So on this particular line, y is less than 4, I am going to use a dotted line. Now, just like we had to shade on our number line, we are going to shade every value where y is less than 4. So if we go to where our y-intercept is, our y values are getting bigger as we go up because here my y would be 5, 6, 7, 8. It is getting smaller as I go down, 3, 2, 1, 0, and so forth. Since I want everything less than 4, we are going to shade everything, not like that, everything less than our line. Now what this means here is I should be able to plug in any point that's being shaded over to my equation and it should work. So if we were to pick the point 2, 0, I should be able to plug it in to y is less than 4 and it should work. Here my x is 2, my y is 0. So if I plug in 0 for y, 0 is less than 4, so I know it works. Let's try another one. So if I were to graph the line y is greater than or equal to -5. Let's try that one. So first we're going to graph our line. So just like if we had if we had y equals -5, we are going to have a horizontal line at -5. I'm going to plot a few points here. And this one is underlined. So this one is going to be a solid line at y is -5. Now I have to figure out where to shade. I want everything greater than -5. So if we look at our y-axis here, it is getting bigger as you go up. So I'm going to shade everything bigger than -5. Now to check my shading, I'm going to pick a point, any point. I'm going to pick 0, 4. I should be able to plug this in and it should work. Sure enough, 4 is greater than or equal to -5, so it works. Now look at the difference between the two graphs we've already graphed. On this one, we had a dotted line. So if I were to pick one of the points that's being shaded over, like 6, 4, This should not work on my equation because I have a dotted line. If I plug in 4 for my y, 4 is not less than 4, so it does not work. On this line, however, we have a solid line. So if I pick this point right here that is on the line, which is 0, -5, it should work. If I plug in -5 for my y, -5 is greater than or equal to -5. So I know this one works. Now, we are also going to graph lines that are in slope-intercept form. So let's graph the line y is less than or equal to -1/2 x plus 3. Now, in order to graph this line, you're going to follow the same steps that you would follow in just graphing a normal line that's in slope-intercept form. So here, my slope, whatever's being multiplied to x, is -1/2. Okay, my y-intercept is 3. So I'm going to go to where my y-intercept is 3, 0, 3. I am rising -1, and I am running +2. So I'm going to go down 1 over 2. Down 1, right 2, and so on. Now here, my inequality sign is underlined. So I want a solid line to connect my points. Okay, now we have to figure out where to shade. You can either follow the same steps that we did before and look at your y-intercept to determine which way to shade. I want everything less than or equal to my y-intercept. So I want everything down because my y's are getting smaller this way. If that is confusing to you, you can also pick a point and plug it in to see if it should be shaded over. For example, I'm going to pick the point 0, 0 just because it's the most simple to plug in. If I plug in 0, 0 here, I'm going to determine if I should shade that way or if I should shade the opposite way from my line. So I'm going to plug this in to y is less than or equal to -1/2 x plus 3. I'm going to plug in 0 for both my x and my y. So this becomes 0 is less than or equal to -1/2 times 0 plus 3. This 0 here is just going to cancel this out. So I'm left with 0 is less than or equal to 3. Since this is true, then I want 0, 0 to be shaded over. So I'm going to shade this way. I want everything less than my line. And we're done. Let's try one more just to be clear. I'm going to graph the line y is greater than, let's say 4x minus 6. So using slope-intercept form, which we should be used to by now, my slope here is 4 and my y-intercept is -6. So I'm going to go down to -6. Here I'm rising 4 and I'm running 1. So I'm going to go up 4, 1, 2, 3, 4, right 1, up 4, 1, 2, 3, 4, right 1, and so forth. Here I have just a greater than symbol. So it is not underlined, so I need a dotted line. Make sure yours is dotted. And now I have to determine where to shade. So I can either look at my y-intercept and know that I want everything greater than my line, so I know I need to go up, or I can do what I did before and plug in a point. Now, say we plugged in a point that it didn't work. That means we want to shade the opposite way. If my point does work, then I want to shade in that direction. So let's plug in 0, 0 again. You can always plug in 0, 0 unless your line goes through it. If your line is going through it and it's dotted, 0, 0 will not work. So I'm going to plug this into my equation. So we have 0 is greater than 4 times 0 minus 6. So we have 0 is greater than negative 6 because this cancels out. This is true. So I want to shade in the direction of 0, 0. So I'm going to shade everything to the left of my line. We cannot forget to shade on inequalities because any of these could be a solution. So quick recap. You should be good to graph linear inequalities if you are okay with slope-intercept form. If you're okay with this, you should be good. We could plug in any inequality right here and graph it. Now remember, just like on our number line when we had an open circle, this stands for our less than and greater than symbols. We are going to use a dotted line for these. Alright, and just like when we had a closed circle on our number line, we are going to use this for our less than and equal to and greater than or equal to. We will use a solid line for these graphs. Also, do not forget to check your graph by plugging in a point that is shaded over.